Series and parallel circuits. Hello, I think it's important to preface this discussion about series and parallel circuits with a little information about myself. I've decided to do this as a PowerPoint presentation, quite simply because I didn't have time to comb my hair. I'm sure you'll all understand from the small picture of me below that there's a lot of it, and it may take a little bit of time. Series circuits. The definition of a series circuit is a closed circuit in which the current follows one path, as opposed to a parallel circuit where the circuit is divided into two or more paths. In a series circuit, the current through each load is the same, and the total voltage across the circuit is the sum of voltages across each load. Quite simply put, a series circuit is inherently similar to a well-planned road trip. You know where you're starting from, where you're going, and every McDonald's location in between. This makes the trip quite easy and results in minimal disturbances. In short, you completely disregard your mate Jeff's decision to take a shortcut, because doing so would make your road trip into a parallel circuit, and that's illegal in most states. Imagine for a moment a hula hoop. Yeah, one of those purple things. Add a battery, a few resistors, and a capacitor, or two, up to you, and you have a simple series circuit, given that your hula hoop is conductive and you have everything attached in the correct direction. This analogy makes it easy to understand the flow of current around a series circuit. Or circus. Up to you. Looking at this circuit, we can see that current flows from the battery, through the hula hoop, wires, into a resistor, through the capacitor, and back into the battery, completing the circuit. In a series circuit, there can be multiple resistors, voltage sources, and capacitors. The total resistance of a series circuit can be found by simply adding each resistor. The total capacitance can be found by adding the inverse of each capacitor, then dividing 1 by this new inverse capacitance, as you can see from the small example below. Voltage sources can be simply added. Parallel circuits. A parallel circuit is a closed circuit in which the current divides into two or more paths before recombining to complete the circuit. Each load connected is a separate path, receives the full circuit voltage, and the total current is equal to the sum of the individual branch currents. Like a series circuit, a parallel circuit can be likened to a road trip. A very long road trip for a family gathering. Only you're not driving, and your grandma needs to get out every 5 minutes for a stretch. Also, your dad forgot to put petrol in the car, mum left the gift back at home, and your sister gets lost at some point. If we look at this parallel circuit, we can see that the current is delivered to the circuit by the battery. This current then flows to the junction between the two resistors, and splits between them. The voltage will be the same between the two resistors. The current that enters the node at the parallel resistors will be equal to the sum of the currents in I1 and I2. The total resistance of the circuit, along with the total capacitance, can both be found, however the ways to do so differ from a series circuit. To find the total resistor of a parallel circuits, you divide the resistance and follow the small example given here. To find the total capacitance of a parallel circuit, you simply add the capacitance of the individual capacitors. You may notice that the rules are simply the opposite of those for a series circuit. Sometimes this can be useful if you are struggling to remember them.